Hi there. In this video, we'll continue the discussion of complex numbers. So just as a review, a complex number is a number of the form, say, 3 plus 2i, where 3 is the real part, so it comes from the real numbers, and 2i is the imaginary part because it has the I. And remember, I is equal to the square root of minus 1. So this is not a real number, so that's why we call it imaginary. So some of the things in the other videos that you may have seen is how do you add and subtract this. So if I ask you to simplify, 7 minus 1 half I minus 3 plus 3/4 I. So the way you add or subtract is we combine the real parts and we combine the imaginary parts. So this is going to become, and I'm going to get rid of parentheses first. So distribute that, since I'm subtracting, distribute that negative. So minus 3 minus 3/4 I. And now you can combine for the real part, it's 7 minus 3, and the imaginary part is going to be negative 1 half I minus 3/4 I. And so here, 7 minus 3 is 4, and I could have just written 4. And the imaginary part, well, we have to do the negative 1 half minus 3/4. So I'm going to do that on the side over here. Negative 1 half minus 3/4. So we need a common denominator. So the common denominator is 4, which means that one already has the 4, but this one needs to be multiplied by 2. And so I'm going to have negative 2/4 minus 3/4, which is negative 5/4. So this will be the imaginary part. So I go back to my problem, and so I'm going to have minus, so I can get rid of that plus there, minus 3/4, or sorry, 5/4 I. And that will be our final problem. 4 minus 5/4 I. And that will be the subtraction. So that's just to recap a little bit of what you may have done in the previous videos. So now, how do you multiply complex numbers? Now, one of the things to keep in mind here is that whenever you do multiply I times itself, you get I squared. And remember, I is the square root of negative 1. So that means when we have I squared, this is really the square root of minus 1 squared, which is negative 1. So let's try some examples of multiplying complex numbers. So say I want to multiply 5 minus 3i times 2 plus I. And so here we treat it just as we did with polynomials before. So you can use the distributive property or you can use the box method. So I'm going to do the box first. So I'm going to do 5 and then minus 3i and 2 and positive I. So I'm going to do 5 times 2 is 10. 5 times I is 5i. Negative 3i times 2 is negative 6i. And negative 3i times I is going to give me a negative 3i squared. But we just set up here that I squared is negative 1. So this becomes negative 3 times negative 1, which then is positive 3. And just as we did before with polynomials, we can combine, or like terms are going to be in the diagonal of this box method. And so you're going to get the 10, negative 6i plus 5i, which is negative 1i, and the plus 3. So combine like terms, 10 plus 3 is 13, and negative 6i plus 5 we already said is minus 1, so I just said minus I. And so this will be my final answer. You can also just use the FOIL method, right? We do the first So that's 10, the outer, that will be plus 5i, the inner, minus 6i, and the last, minus 3i squared. And so here we have 10 minus I, and again the I square is minus 1, so you have minus 3 times minus 1, and that becomes a plus 3. So you get 10 plus 3, 13 minus I, and we get the same answer. So it's really just preference. Which method do you prefer? Let's try another one. B, if I do 4 minus 3i times 4 plus 5i. So go ahead and pause the video and try this on your own and see what you get. And then you can resume and see if we got the same thing. So if I'm doing the box method again, I'm going to do my 4, my minus 3i, my 4, and my positive 5i. And we do the same thing. So 4 times 4 is 16, 4 times 5 is 20 with the I, negative 3i times 4 is negative 12i, and then here I'm going to get the I square. So negative 3 times 5 is negative 15, but I get the I square. And so here I square is negative 1. So this really becomes positive 15 after we substitute the negative 1. So our final answer then will be 16 plus 8i plus 15. So what is that? 31 plus 8i. Good job if that's what you got. So one of the other ones for multiplication, what if we multiply conjugates? So say I want to do 2 minus 7i times 2 plus 7i. So conjugates is when the middle sign is different. So same thing, let's multiply. I'm going to do this one by FOIL. So when I do 2 times 2, I get 4. 2 times 7i is positive 14i, and then negative 7 times 2 is negative 14i, and then minus 7 times positive 7 is negative 49, but then you have I times I, which is I squared. And again, this I squared is equal to negative 1. So our final answer, well, close to our final answer, I'm going to have 4. Notice that here, this middle terms go away. And I'm going to have minus 49 times negative 1, which is actually plus 49. So this becomes 53. And that is our final answer. So notice that when you multiply conjugates of complex numbers, you end up with the real number. The imaginary part goes away because the imaginary part comes from those middle terms. And so that goes away. So let's try, how do you divide them? So that was multiplying them. So dividing them, let's start with an example. What if I have 7 divided by I? So how do you simplify that? Well, remember that I is the square root of negative 1. So you really have 7 divided by the square root of negative 1. So this, we want to treat it like a radical. So we want to, well, it is a radical, but we want to rationalize the denominator. So I'm going to say multiply by the square root of negative 1, multiply by the square root of negative 1. And so I'm going to get 7 square root of negative 1 over negative 1. Negative 7 square root of negative 1. Now, of course, we don't change the I to the square root of negative 1. So what we actually, the way that you're going to see it in your book and the way that we do it is we say, okay, I want to get rid of the I in the denominator. So we're going to multiply top and bottom by I. Right? This is equal to 1. So I'm not changing the value of the fraction. So now I'm going to get 7i divided by I squared. And again, I squared is equal to negative 1. So then this is 7i over negative 1, which gives you negative 7i. Notice that it's the same thing. Once you substitute the square root of negative 1 for I, we get the same thing. So along those same lines, what if I had something like 2 minus I over 3 plus 5i? Now remember that the I is the square root of -1, so this is really like a radical problem that you're trying to rationalize the denominator. So I am going to multiply by what gives you a real number. When you multiply a complex number is, as we did above, is the conjugate. So I'm going to multiply by 3 minus 5i, top and bottom. And so on the numerator, we're going to have 2 minus I times 3 minus 5i. So our multiplication practice above is going to come in handy. Here is their conjugates. So I'm just going to get 3 times 3, which is 9. And remember, our middle terms go away. So I'm just going to get 5i times negative 5i, so minus 25i squared. So continuing simplifying, now I can multiply these out. So I'm going to get 6, and what's that, minus 10i, and then minus 3i, and then plus 5i squared. The whole thing divided by 9. Negative 25 times, remember this is equal to -1, so that becomes plus 25, and hence a real number. So this becomes, so this here, remember the I square is equal to -1, so that becomes -5. So 6 minus 5 is 1, minus 13i over 25 plus 9, so that's 34. And that will be our answer. So think of it as when we did radicals and you were rationalizing the denominator, we multiply by the conjugate. So here is very similar. We multiply it by the conjugate, middle terms go away. It's just that that second term you get an I square in there, and I square is -1. Some of the things that you might see come up is, and to remember, is that I is the square root of -1. I square is this square root of -1 square, so you get -1. I cube is I squared times I, so therefore is -I, and I to the fourth, I think of it as I squared times I squared, which is then -1 times -1, which is +1. So the four things to remember are that I is equal to the square root of -1, I square is -1, I cube gives you -I, and I to the fourth gives you +1. And so these are helpful when solving problems like what's I to the 10th power, for example. And there are different ways that you can do it, but I oftentimes think of it as, well, how many I to the fourth can I get there? So it'll be I to the fourth times I to the fourth, that gives me 8, and then times I square. And then I can substitute these values, so that's 1 times -1, so the whole thing is -1. So this one's not too bad, but what if I had something like I to the 23? What is that? And so I tend to go for I to the fourth because I to the fourth is 1. So I'm going to break this up as I to the 20th times I cube. Right? Because I to the 20th is I to the fourth to the fifth times I cube. And I to the fourth I know is 1. 1 to any power is 1. And then from here I know I cube is -I. So my answer is -I. Now somebody else could come and say, well, I know that I square is -1, so I'm going to write I to the 23rd as I to the 22nd times I, because that gives me 23. And then I to the 22nd is I squared to the 11. And I squared is -1. So you have -1 to the 11th power times I. Oops, sorry, that should be a times, not an equals. And -1 to an odd power stays negative, so this is -I. So we get the same answer, a different approach. All right, let me know if you have any questions with complex numbers.